Hi class, so this is part 2 of 9.2, so it's 2.2, part 2, 9.2. Okay, so previously we had answered our little table or filled out the table for both 0 degrees and 30 degrees, and we are now on 45 degrees. Now, I like to show you how to do these and then let you determine your own way of doing them, and a lot of people just look at a unit circle or they copy down the unit circle on these. I don't like that way as well because I know it says memorize them. It takes a long time to memorize them, and we have a lot of things in our head already, and we can find them fairly easily in the way I'm showing you. So I don't memorize. I just draw my triangles every time and figure them out that way. And then I don't have to memorize as much. You still have to memorize a little bit. But what I do is I take my degrees, so 45 degrees, I know that's right there. Okay, I draw the reference angle. So that reference angle comes down to the x-axis, and I know it's a 45-degree angle right there, so I know my sides are 1, 1, radical 2. So I set the sides up on the triangle, and then I can find the cosine, because I basically have to find cosine, sine, and tangent on every single one of them. So once you draw that in, then you're in good shape, because then you can just use your SOHCAHTOA and come up with your side measures. So I like to do that first, and then fill out the right side of the table. So sine of theta is y over r. So this is y is 1, r is radical 2. The radius is the hypotenuse in this case. So 1 over radical 2, and that simplifies to radical 2 over radical 2, or sorry, you times by radical 2 over radical 2, which simplifies to radical 2 over 2. All right, that's your sine. Your cosine is also, it's adjacent over hypotenuse, so adjacent is 1 over radical 2, which again simplifies to radical 2 over 2. All right, your tangent is just opposite over adjacent, which is 1 over 1, which simplifies to 1. So our coordinate is going to be cosine sine, so radical 2 over 2, radical 2 over 2, which we just found over there. And then in radians, remember that we take our 45 degrees and we times by pi over 180. And 180 divided by 45 to simplify. Remember, you have to simplify next. So 180 divided by 45 is 4, so you can divide 45 into 45 and get 1, and 45 into 180 is 4, so that's pi over 4. All right, there's another one. So 60 degrees, I'm trying to find a good spot to write these. So a 60-degree angle, right there is my terminal side at 60 degrees. That's 60. With the 60, that means this one's 30, and across from the 30 is 1, hypotenuse is 2, and the longer side is radical 3. So you just have to remember those nice little, oh, where did everything go? So we have 1, 2, radical 3, and a 60-degree angle. So with the 60-degree angle, and this is theta right here, so that's where we're going to base our sine, cosine, and tangent off of. So again, I'm going to go over to sine. Sine is opposite, which is right there, radical 3 over 2. Sine is radical 3 over 2. Cosine is adjacent 1 over hypotenuse 2, and tangent is y over x, opposite over adjacent, which is radical 3 over 1. Right? Not too bad. So first, this xy is cosine theta, sine theta, remember? Xy. So cosine is 1/2, sine is radical 3 over 2. And then we take 60 and times it by pi over 180. 60 goes into 60 once and 183 times, so that makes pi over 3. Okay. Now, these last three are those quadrantal angles I was talking about previously, and I like them a lot better. They're a lot easier. With these quadrantal angles, remember r is always equal to 1. So if r is 1, what I do is I draw my coordinate plane, and 90 degrees is right here, so that's your terminal side, and you make a point on it. And what is that point? It is 0 over and 1 up. Because remember, r is always 1, so we're always moving in units of 1, so 0, 1. So with that 0, 1, and our r equal to 1, our sine is y over r. So y is 1, r is 1, so that's 1 over 1, which is 1. Cosine is x over r, so x is 0, over r is 1, so that's 0. And then our tangent is y over x. Y is 1 and x is 0, which is undefined. Okay? Now, so our cosine is 0, sine is 1 for our xy, and then 90 times pi over 180. 90 goes into 90 once and 180 twice, so it's just pi over 2. Okay? All right, 180 is equal to pi, so at least we know that. Or when we times by pi over 180, the 180 is divided away, we just have pi. And then on our axes, 180 is right here, so our point there is going to be -1. I'm just going to write it here. -1 over and 0 up. Those are a little bit easier to just find your x and y because they're right there. The x is -1, the y is 0. So the sine of that is y over r. So y is 0, r is 1, so 0 over 1, which is 0. And then cosine is x over r, so x is -1, right there, over r, which is 1, so -1. And then tangent is y over x. Y is 0. X is -1, but 0 over -1 is just 0. All right? See how much easier those are. So the 270 is right here. That's your 270. So our point's there, which is down 1, 0 over down 1. Right? 0 over down 1, so 0, -1. So x is 0, y is -1. So 0, -1. All right, so the y is your sine, y over r. Y is -1, r is 1, so that's -1. Cosine is x, which is 0, over 1, which is 0. And then y over x, y is -1, x is 0, so that again is undefined because 0 is on the denominator. All right, and then for our radians, when we multiply 270, I don't really have, let's move this. Can I move that down? Anyway, when you multiply by pi over 180, let's see, what goes into both? 90? 270 divide 90 is 3. So you can divide and get a 3 on the top, and then 90 into 180 is 2 on the bottom, so you have a 3 and a pi on top, and a 2 on the bottom. And that is the rest of that. So anyway, that's how I find them. If they're on the quadrants, I just mark the point using 1 as my units because it's a unit circle. And then if it's a triangle, I make the triangle, and with those 45, 45, 90 sides of 1, 1, radical 2, and the 30, 60, 90 sides of 1, 2, radical 3. And then I just use my y over r, x over r, and y over x, depending on the function I'm asked to find the ratio of the sides for and come up with our actual function. All right, so signs of trig functions, and looks like I have a few minutes, I could probably get through this. Trig functions are all of a sudden positive in some quadrants and negative in some quadrants. So what happens is, in this quadrant, if I pick out points in this quadrant, my x is positive and my y is positive, whatever it is. If x is 2 or 3 or 4, or y is 2 or 3 or 4, whatever they are, they're both positive. Now, when I have points in this quadrant that could be on a terminal side, all of a sudden my x's here are always going to be negative because I'm always traveling backwards and then up. My y will be positive. See how that works? And then if I have a point on this side with that are terminal points in the axis, then both my x and my y are negative. So I have a negative x and a negative y in this quadrant. And what's going on in this quadrant, if I have any points with a coordinate that are on that terminal side of an angle, then my x's are positive, but I've traveled down to get my y's, and that makes my y's negative. Right? So that's what happens every time. My points in those quadrants are always negative or positive depending on which quadrant it is. Now remember, in my unit circle, R is 1, which is positive. So the R is positive. Now what's going to happen here is X and Y are both positive in the first quadrant, and so is R. So whether I take a ratio of X to R or Y to R or X to Y or Y to X or R to X or R to Y, whatever the case, I'm always going to have a positive X over R, positive Y over R, or a positive Y over X, or so far and so forth. So all functions are going to be positive in this quadrant. So I'm going to have, I don't really have any room. All those functions are going to be positive. I'm just going to erase this and write. So all functions are going to be positive. So that means sine theta, which is y over r, is positive because y is positive, r is positive. We have a positive x, a y, and a r in quadrant 1. So cosine theta is positive and tangent theta is positive, and then all their reciprocals, which are secant theta, cosecant theta, and cotangent theta. Every single of the trig functions are going to be positive because my x, y, and r are positive. Now what happens in quadrant 2 is I have a negative x, a y, and a positive r. So anything with an x in it will be negative and therefore make it a negative solution if x is in it. So the only thing that will be positive is y over r or r over y. Those are the only ones that will be positive. And r over y, or y over r, let's see, y over r is sine, and then its reciprocal, y over r, opposite over hypotenuse. Y over r is sine, and then r over y is cosecant theta, and it will also be positive, its reciprocal. All right? Because in this second quadrant, you're going to have a negative x, a positive y, and a positive r. Your radius, is always considered positive. So cosine negative x over r is negative. Secant, its reciprocal, r over negative x is negative. Tangent, y over negative x, negative. Cotangent negative x over y, negative. The only thing that's positive is sine y over r, or its reciprocal, r over y. And then quadrant 3, I'm going to actually erase this to get rid of it before we go over quadrant 3. Okay. It's a little lag, apparently. So quadrant 3 would be something like this. What happens in quadrant 3 is our x is going left, so it's negative, our y is going down, it's negative, and then, of course, r is always positive. So looking at sine is opposite over r, so negative y over r, that's negative. Cosine is adjacent over r, so negative x over r, that's negative. Cosine is negative. But tangent is negative y over negative x. So negative y over negative x becomes positive y over x, and therefore tangent theta is positive. And also if I do negative x over negative y, cotangent theta is also positive. So those two will be positive. All right? And then quadrant 4 is right here, and it's a positive x, a positive y, or negative y, and a positive r. Because you're going down with y, then that makes it negative. All right? So that means x over r cosine is positive, and so is r over x, which is secant. It's reciprocal. So those two are positive. Negative y over x, or negative y over r sine is negative, and so is cosecant. R over negative y is negative. And then tangent, negative y over x, and cotangent x over negative y, they'll be negative because they have a negative. Did I test them all? I did. Just to show you, I didn't actually do that, and I thought of it halfway through here. If this is x, this is y, and this is r, that's why everything's positive in the first quadrant. y over r is positive, r over y is positive. So sine and cosecant are positive. And then x over r and r over x, cosine and secant are positive. And then y over x or x over y, tangent and cotangent are positive. All right, so, ooh, dang it. I better stop this and move on, and hopefully it will work because I'm out of time.